In problem 13, we are going to solve the rational expression by graphing. I have this already pre-graphed in Desmos, so I can draw a nicer graph for you and see where they actually connect. Honestly, if you are solving by graphing, you want to use Desmos. You don't want to try to graph this on your own. So the first thing I'm going to do is set it up so that my rational expression is all by itself. So I'm going to minus 1 from both sides. Now I'm going to determine the domain. The domain is all numbers that make it so the denominator cannot be 0. So the only number that's going to make the denominator equal to 0 is 1. So we're going to have all real numbers except for 1. Our horizontal intercept is when y equals 0. So we're going to set this equal to 0. I'll do this in red. Multiply both sides by x minus 1. Divide both sides by 3 and we get x equals 0. So our horizontal intercept is going to be at 0, 0. So our vertical intercept is also going to be at 0, 0, but I will show my work to prove that. What I'm going to do is set x equal to 0 and find y. So our vertical intercept is also 0, 0. Now we have to find our asymptotes. Our horizontal asymptote, we have the same degree on the top and the bottom, so the horizontal asymptote is going to be y equal to the ratio of those. So 3 over 1 gives us a horizontal asymptote of y equals 3. Our vertical asymptote is going to be x equal to any numbers that's not allowed in our domain, and the only number not allowed in our domain is 1. So I am going to graph y equals 2, because this is where we want to see where this graph crosses. There we go. Next, I'm going to graph our vertical and horizontal intercepts, both at 0, 0. So we know our graph is going to go through 0, 0. I will then graph my horizontal asymptote, y equals 3. And our vertical asymptote, x equals 1. So here's what our graph looks like. Goes through 1, 1, 0, 0. And it actually goes through negative 2, 2. So our solution, you'll see it much clearer in Desmos. Our solution to this problem is x equals negative 2.